Hello, welcome to today's science lesson. We'll be looking at evidence of change from fossils and rock formations. Okay. So hopefully you've all watched my last video on fossils, so you understand everything for today's lesson. And make sure you watch to the end of today's video. Okay, so we're going to be looking at fossil clues. What can we learn from fossils? So if you remember from our last lesson, we talked about the law of superposition. Now that just means that when rocks get laid down, you end up with the oldest one on the bottom, keep going on top, and you end up with the youngest one at the top. So maybe the one at the bottom is 1,000,000 years old, the one at the top is only 1,000 years old, maybe. Okay, so I want to talk about pollen. So if you all think back and remember what pollen is. So pollen is the kind of dusty yellow stuff, like little balls, really, really tiny, and it comes out of flowers, and it helps them to make baby flowers. Okay, it comes out of plants, lots of different plants, actually trees as well. Helps them to make babies. So pollen. When we look at the pollen of different plants, so if you can see that the this yellow flower above me, it has red pollen, and it's kind of a round shape. And then the tree here has diamond-shaped pollen. It's orange. And then this bush, Mr. Bush has blue. Octagonal-shaped pollen. So pollen from different plants can look different. Okay, and pollen can also be fossilized. So like the dinosaur bones get fossilized and stay there for millions of years, so can pollen. Now that's really useful because we can look back at some rocks and you can see all this different type of pollen. Obviously the pollen is really, really tiny. You need a microscope to see it. But we can look at all the pollen in the rocks and then we can say, look, well, I know that this type of pollen with the red balls, red round pollen, I know that was yellow flowers. So you can say when this layer of rock was formed, there was lots of yellow flowers. Easy, right? Okay, so we can carry on doing that. We can look at the yellow diamonds. Oh, apparently we're skipping them. We can look at the blue octagons and we say, there must have been lots of bushes around when this layer of rock was put down. And obviously you can have lots of different types. So it doesn't just have to be one type. You can say, there must have been a lot of yellow flowers and trees when this layer got put down. So it's very useful for learning about what the environment must have been like a long time ago. Because we can look at the rock layer that says, we can look at the rock layer and see what's in it. You can see what plants were growing at that time. Okay, I'll give you another example. If we looked at a rock layer and it had lots of shells in it and fish bones, what can we guess about the environment? Yeah, well, we can guess that it's probably underwater, and maybe that cliff has risen up or the sea has dropped down, and now it's on land. But obviously at one point that must have been underwater. If there's fish in there, you don't get fish on land, do you? So you can learn a lot from the types of fossils you find in a rock. Another interesting thing you can do is you can look at where fossils are found on the planet. So if you find some fossils on the west coast of Africa, and you find them also on the east coast of South America, you can think, oh, maybe those two continents used to be joined together. Very interesting. So that's how they realized that the continents have been drifting and moving apart over millions of years, because animals used to be found on different sides of both of them, showing that they used to be together like a jigsaw puzzle. Right. So I want you to imagine a story. Okay. So I'm going to make up a story. I want you to imagine that one day, just for one day, 65 million years ago, it started raining marbles all over the planet. The whole of the planet, for one day, started raining marbles. Okay? Just imagine that happened. So all these marbles went onto the rock, and over millions of years, new rock gets put on top. More new rock, more new rock, more new rock. Yeah. So then we can look at this layer of rock and we say, how old is this layer of rock? Well, we know it happened 65 million years ago. So this layer of rock here at the bottom must be 65 million years old, right? Okay. So that's easy enough. So now if we look at a different rock, okay, so we've got a different rock here, and we look down and we see there's this one layer and it's full of these marbles. Now we have to guess how old this bit of rock is. Now this is a different rock, so we don't know the ages of the different layers, but maybe we can guess, because we know that the marbles fell 65 million years ago, right? We know that all over the planet marbles fell 65 million years ago. So if we look at this layer of rock, this is in a different rock, we can guess that this layer, yep, you guessed it, yeah, this layer must also be 65 million years old. Okay, great. So we have a name for this. Okay, so you see that we used what we know about one layer of rock. We used that to learn things about a different rock. Okay? So we know that this layer has marbles in. So we know that any rocks that we can find on the planet that has this layer of marbles in, we know is also the same age, 65 million years old. Okay. But obviously I made this up. It didn't really rain marbles, I'm afraid. I just made it up. So, but we have a name for this type of layer. This type of layer that we can use to learn stuff about other rocks, because we know we're going to see it everywhere. We call it can you guess? A key bed layer. A key bed layer. That's what we call it. And they're really useful. Helps you learn things about different rocks. Okay. Now we're going to talk about mass extinction. So what happens in a mass extinction? Everything dies. Well, not everything, but if the dinosaurs go extinct, then all the dinosaurs, they die. Very sad. Okay, so pay your respects, right? Okay, so I don't know if you know, but when the dinosaurs went extinct, it was because a huge asteroid came from space, and it crashed into the ground, and it sent up lots of ash, lots of smoke, lots of fire. Yeah, and all the ash and smoke that went into the air from the fires blocked out the sun, causing all the plants to die. The temperature went really cold, and yeah, all the dinosaurs died. Very sad. But you're very lucky that I've managed to find one videotape of it happening. You're very lucky because obviously they didn't have many smartphones back with the dinosaurs, so not many videos of it. But yeah, I found you. Oh, there it is. Whoa! It's only a very short video because obviously they didn't have many video cameras. Okay, so you see all these asteroids, or maybe it was just one. I'm not sure. Maybe just one big asteroid came down and it destroyed all the dinosaurs, caused an extinction. Okay, so when an asteroid hit, I said lots of smoke went up, and all the plants set on fire. Okay, so there's lots of smoke and ash. You know, ash like the black stuff when you burn something. Yeah, so all that black stuff was in the air. Okay. So when all that black stuff landed on the ground, it caused this layer in the rocks. So when new rock got put on top, this layer stayed there. Okay. So just like the marbles we talked about was the same layer, and you can see it everywhere around the planet. That's what happened with the extinction of the dinosaurs. So we have a name for this layer. We call it the KT boundary. Yeah, KT boundary. You don't need to worry about what that means, but just learn the KT boundary. So the KT boundary is let's go back. It's a key bed layer, okay? Because when the asteroid hit, the ash and the smoke, it went all around the planet. So everywhere on the planet, you can find this KT boundary. If the rock is old enough, you can find that layer. Okay, so that layer is made of all this burnt stuff and dead animals. So when I made up that story about the marbles landing, it wasn't completely a lie because it wasn't marbles. It was a huge burning asteroid that crashed into the ground. So now if we look at a rock, you can see that we'll have all these happy dinosaurs living away their little dinosaur lives, and then you have the KT boundary, and after there, no dinosaurs because they all died. But that's good because probably you wouldn't want to meet a T-Rex in the park because maybe it would eat you. Right, that's the end of my video. If you watched the whole thing to this point, then well done. You can have 20 magic points. And so I know that you watched the whole video until here. You have to include the sentence "I love T-Rex" in your email when you send it to me and Miss Liu with your other work. Okay? Great. Goodbye.